All right, number 13 is there just to remind you to review your unit circle values. That should be the easiest part of the test for you. It's the first part of the test in the calculator section. And it really should be the easiest section of the test for you. All right, graphing trig functions is our next part of the exam review. It wasn't next in the flow of the year, but it was close. All the trigs that was coming together, and that's helpful. Remember, when we're writing equations for our trig functions, here's the form that we use: a sine of bx plus b, and then plus b or minus. Remember, a is your amplitude or your height from the midline. B comes from 2 pi divided by b is the period of the function. D is your vertical shift. Up or down, that moves the midline and then the curve around it. Also remember that B is your horizontal stretch of strength, so that helps you to think of it that way instead of using the period of the function. And then C is your phase shift. Well, C is part of your phase shift. Your phase shift is B divided by B if you're given this form. You can also factor out your B when you're writing your equation, and I think that's more helpful. So I'll do it both ways when I'm writing these equations on these videos, and I have that both ways on the exam review, so that you can decide what you like and stick with it. Okay, for number 14, I'm always going to rate the easier equation first. And since we're starting at 0, 0 on our midline, the sine equation is easier. Here, our amplitude, the height of the curve, is 2. Since we're starting at 0, 0, I'm not going to have a phase shift. That's what makes the equation easier to write. And I don't have a vertical shift as well, so you can put plus 0 or just leave that point. The last thing I need to deal with here for my sine equation is the period of the function, and that's going to drive this b. So I have 2 cycles on my picture. 2 cycles is 12 pi, which means 1 period of the function is 6 pi. Again, for a period of the function for sine, we're looking for a cycle above our midline and below our midline. So 2 pi divided by b is equal to the period of our function. The period of our function is 6 pi. I think it's helpful to put that over 1, and then you can cross multiply and divide. 2 pi times 1 equals 6 pi times b. Divide both sides by 6 pi. 6 pi's cancel, your pi's cancel, and 2 over 6 is 1/3. The nice thing about writing your cosine equation is that everything's going to be the same. You're just going to have a phase shift. So I'm going to bring down my 2. I'm going to have cosine instead of sine. My 1/3 I'm going to use. And if I didn't have a vertical shift with sine, I don't have a vertical shift with cosine either. Now I just need to decide where my cosine graph starts. I like to start cosine. Well, cosine starts at either a maximum or a minimum. If you start at a maximum, then you don't need any kind of reflection. So if I start here, I just need to figure out where here is. It looks like my graph is broken into pies, so it's right between 1 pi and 2 pi. The other way you can, to figure out exactly what that is, here's 6 pi. That means halfway back, remember our graphs are always broken into fourths, so I can break it into half, and that's going to be 3 pi. And half again is going to be 3 pi over 2. So I'm going to use my phase shift equation to get C. My B is 1/3. And my phase shift, that's equal to my phase shift. I'm just using this equation here. Phase shift equals C over B. My phase shift is 3 pi over 2. So it's a little tricky with these fractions happening, but we're going to multiply both sides by 1/3. Don't flip that fraction. You're dividing by 1/3, so multiply both sides by 1/3. There, my 3's are going to cancel, so I'm going to be left with pi over 2. And it's pi over 2 to the right, so I'm going to minus pi over 2. The other way that you could deal with that phase shift, which I actually kind of prefer, is like this. You just have to remember an extra set of parentheses. My phase shift is 3 pi over 2. And then if you needed the just A, B, C version, you would multiply 2 to the 1/3. So it's the same math that we were doing. It's just a different way to write it. The key here is to remember those parentheses. If you're going to forget those parentheses, then you've got to do this C over D. Okay, a couple more sine and cosine examples. This is another graph that's going to be easier to write as sine. So I know that because we're starting at 0, 0. Here my graph is scaled in 2 pi's. Up here is 8 pi. And my amplitude is 4. So 4 sine. I'll figure out what B is in a minute. And I don't have any vertical shifts to this one either. So to find my B, 2 pi over B equals the period of the function over 1, and that the period of this function is 8 pi. And divide both sides by 8 pi. 8 divided by 2 is 1/4. Just like the last problem for our cosine equation, we're going to use each piece of the equation above. We're just going to have a phase shift. And the phase shift, we're going to deal with it just like we did for the last problem. So I'm going to write phase shift equals C over B, and I'm going to plug in my B value and my phase shift. Let me write that out for you. Phase shift my B here is 1/4, and my phase shift, oh, this one's on a nice spot, is at 2 pi. Again, I'm dividing by 1/4, so to get C all by itself, I'm going to multiply by 1/4. 2 pi times 1/4, 2 over 4 is 1/2, and I have a pi left on top. And I'm doing that pi over 2 to the right. Again, just like with the last problem, if you can remember the rule that you need those parentheses, it's a little bit easier, I think, to write the equation. Here's your phase shift instead of your C over B. And then you can multiply the 1/4 through if you need to match. Okay, last example. This example has a vertical shift, so I'm going to dot in that midline. That's the first thing I always do. It's kind of hard to tell what kind of graph you have if you don't. So here, on the y-axis, I'm crossing my midline. That means my sine equation is going to be easier to write once again. My amplitude here, from the midline, I'm going up 1, 2, 3, 4, so my amplitude is 4. We do have this vertical shift. We moved our whole graph, our midline and all, up 2 units. So that's going to go +2 on the outside. And the last thing to deal with is the period of the function. And so one cycle of our function here down and then above. First of all, that my sine is flipped. You can write that as an x-axis or a y-axis deflection. I like to do x-axis, then I don't have to worry about where I can just stick that negative in front. And the period of my function here is pi. So 2 pi divided by b equals pi. Well, 2 pi divided by b equals pi means that my b has to be 2. So if you would like to pause and make sure you can do that math and match that answer, if that you're not just seeing that, that's absolutely fine. The other way you can look at this is this has to be a horizontal compression by 1/2. The normal period of our sine function is 2 pi. And so remember, when we're doing our transformation rules, our horizontal numbers, we take the reciprocal before we decide if it's a compression or a shrink. Or I'm sorry, compression or stretch. So this 2 is actually a compression by 1/2. Horizontal compression. Okay, now we're going to do cosine. Again, I'm using the same amplitude. I'm using the same b value. I'm using the same vertical shift. You can use the reflective one. I don't think I'm going to because I can start my graph right here. So I'm going to be moving my function to the left this time instead of to the right. So I'm going to have a plus. My graph is broken up into fourths. So this guy is pi, negative pi. That's negative pi over 2 here. This max would be negative pi over 4. So that's my phase shift. So if you decided you really like that situation with the extra parentheses, you can put that pi over 4 in and done. If you like the phase shift equals c over b, that's awesome too. Here our phase shift is pi over 4. I already dealt with the negative situation, so I'm not going to worry about that. And our b is 2. So I'm going to multiply both sides by 2 to get c all by itself. And 2 pi over 4 is the same as pi over 2. And that's what we would get if we multiplied these 2 as well. Awesome, that's writing equations for sine and cosine.